Humans have always looked up to the night sky and wondered at the repeating patterns of the celestial bodies. What are they? Where are they from? And what is their connection to us? To answer these questions, we created stories. A sand legend tells the story of the origins of our galaxy, the Milky Way. A young woman waits for the hunters to return at the end of the day. As it grows dark, she throws ash from the fire into the night sky. This becomes the Milky Way and guides the hunters safely home after dark. Everything we know about the universe comes from studying the light emitted or reflected by objects in space. By detecting and analyzing light from an object in space, astronomers can learn about its distance, motion, temperature, density, and chemical composition. Initially, astronomers detected only one type of light: visible light, the type we see with our eyes, which is actually a spectrum of wavelengths that make up the colors of the rainbow. Light travels very fast. The speed of light is about 300,000 kilometers per second. This means that the light from the sun, which is 150 million kilometers away, takes just over 8 minutes to get to us on Earth. So, when we look at the sun, we're actually seeing it as it was about 8 minutes ago. We are looking back in time. Most objects in the universe are even further away, and light from the most distant galaxies can take billions of years to reach us. The South African Astronomical Observatory, or SAAO's headquarters, are located in the suburb of Observatory, Cape Town, where South Africa's first permanent optical telescopes were located as part of the Royal Observatory, Cape of Good Hope. Some of the historical telescopes in Cape Town are still used for outreach and public events. Every month, there are talks on astronomy, guided tours of the site, and stargazing. Recently, the International Astronomical Union chose SAAO to host the Office of Astronomy for Development in Cape Town. Its slogan is "Astronomy for a Better World" and is in line with SAAO's belief that astronomy occupies a special place among the many efforts to address development challenges. Astronomy has a unique ability to stimulate thoughts of what is possible. It helps people understand the universe and our place in it, as well as the fact that we and the universe are all fundamentally connected. The site is also one of the last remaining places close to the city where the original ecology of the area is preserved. It supports a wide range of plant, bird, and animal life, including the endangered western leopard toad. Due to increasing light and air pollution in the city, the Royal Observatory joined with the Republic Observatory in Johannesburg and Pretoria's Radcliffe Observatory and moved to Sutherland in the Karoo in 1972. In Sutherland, the remoteness, altitude and weather enable exceptionally dark skies. SAAO's main research telescopes are located at the observing site 15 kilometers from Sutherland. On a plateau 1,800 meters above sea level stand over 20 different telescopes, some owned by South Africa and some hosted for international research institutes. The oldest operational telescope in Sutherland is the 1.9-meter telescope, which was built between 1938 and 1948. It was previously at the Radcliffe Observatory in Pretoria, where it was the biggest telescope in South Africa at the time. We're now standing inside the 1.9-meter telescope building. This telescope is a real workhorse, where astronomers used to spend the night and perform their observations manually. Recently, the telescope has undergone upgrades and additions to modernize it and allow for remote operations. The Southern African Large Telescope, SALT, is the largest single optical telescope in the Southern Hemisphere and among the largest in the world. Its sophisticated tracking system allows it to follow objects as they move across the sky in order to maximize exposure time. The telescope has a spherical primary mirror array 11 meters across, comprising 91 individual 1-meter hexagonal mirrors. SALT is powerful enough to observe distant details of galaxies so far away that they would be 1 billion times too faint to see with the unaided eye. One of SALT's main functions is to record spectra of distant objects using high and low resolution spectrographs. These instruments split up incoming light into separate wavelengths, which can give us information about the physical attributes of the object, such as its temperature, composition, and the speed at which it travels. Visible light is just part of a broader electromagnetic spectrum. Not all radiation coming from space is just visible light. Many objects emit radiation in other parts of the electromagnetic spectrum which our eyes cannot see. Different types of telescopes are used to detect the different types of radiation. Some celestial objects give off light in a variety of wavelengths, allowing astronomers a more detailed understanding of what is happening. The Crab Nebula is 6,000 light-years away from Earth and is a remnant of a supernova, an exploding star that was observed in 1054 AD. These images are from X-ray, ultraviolet, optical, infrared, and radio wavelengths. These separate images can be combined to give a composite image that can be adjusted to elucidate different aspects of the nebula and how different parts of the nebula interact with each other. This is called multi-wavelength astronomy. This is the Hartebeeshoek radio telescope near Johannesburg, an impressive 26-meter diameter dish that is actively used for research. Together with the MeerKAT telescope in the Northern Cape, they comprise the South African Radio Astronomy Observatory, SARAO. Long wavelength radio waves generated in the universe are collected with large surface area radio antennae. The MeerKAT telescope near Carnarvon combines 64 radio antennae to create the largest and most sensitive radio telescope in the Southern Hemisphere. MeerKAT recently produced the clearest ever view of the region around the black hole at the center of the Milky Way galaxy. A black hole is an object that contains so much mass in such a small volume that even light cannot escape from its strong gravitational pull. These images are derived from X-rays. While this image is a combination of the X-ray images and the radio images produced by MeerKAT. Another example of multi-wavelength astronomy being conducted right here in South Africa is the combination of visible light images from the Meerlicht telescope at Sutherland and the radio images from MeerKAT. By exclusively linking Meerlicht to MeerKAT, we are able to, for the first time ever, provide optical multiband observations of every nighttime observation conducted by a radio telescope, ensuring that every celestial object in the field of view will be simultaneously covered in the radio and the optical. These multi-wavelength observations are being used for pioneering research into transient events. Transients are astronomical objects or phenomena which produce varying amounts of light, either periodically or as once-off events. Transients are often supernovae, which are exploding stars that temporarily give off large amounts of light. They explode when they have burned up all their fuel and disperse elements created in their core into the universe. Recently, SAAO contributed to the observation of a unique transient event in the universe. On Friday, 18 August 2017, the US-based LIGO and European-based Virgo detect gravitational shockwaves in the universe. Within hours, astronomers locate the origin of the event and alert telescopes in South Africa and around the world. SALT decides to drop all other plans and goes for a difficult spectral observation of the object 130 million light-years away. SALT succeeds and produces the first spectrum of the event that shows anomalous behavior, proving that this is no run-of-the-mill transient event. By analyzing the data, astronomers are able to infer that the event was caused by two neutron stars, which are very small and extremely dense, colliding together, creating an explosion of light called a kilonova, visible initially in the form of gamma rays. The collision also created a gravitational shockwave in space-time. This is the first time in history that gravitational waves generated by two merging neutron stars have been detected. The initial explosion of light was then followed by X-rays, ultraviolet, optical, infrared and radio waves, which were also observed. The early SALT observations showed that the explosion was relatively bright and blue. Only 2 or 3 days later, further observations by SALT, SAAO and other major international telescopes showed that the light was rapidly fading and turning red due to the dusty debris blocking the bluer light. This was the first time that gravitational and electromagnetic waves were used together to get information about a celestial event. It was like having an extra sense and provided another layer of understanding. This new form of combined observations is called multi-messenger astronomy. Events like this neutron star merger also create heavier elements in the universe, such as gold and platinum, as extreme gravity and heat fuse the atoms of lighter elements together. When large stars die and explode, they distribute these heavy elements into the universe. Under the influence of gravity, the ejected matter reforms into stars and planets. This is how our solar system and Earth were formed. SAAO's strategy for the next decade will move the observatory into the fourth industrial revolution by combining software, artificial intelligence and advanced connectivity into the African Intelligent Observatory. The optical and infrared telescopes at Sutherland will be tied together into a network that can carry out standard observations and can also respond automatically to triggers of transient events. The telescopes will all be connected to a state-of-the-art remote observing station at SAAO's headquarters in Cape Town, from where astronomers can observe the Sutherland night sky. In building MeerKAT, Soraya is also preparing for one of the biggest scientific undertakings ever, the Square Kilometre Array project. This massive global project will consist of high-frequency antennae spread out across South Africa and other African countries, and low-frequency radio antennae in Australia. Global SKA efforts will be coordinated by headquarters located in Manchester in the United Kingdom. Most of the radio antennae in South Africa will be located in the Karoo outside Carnarvon and will be an extension of the MeerKAT array. The SKA will push the limits of engineering and scientific endeavor over the coming decades. Building the SKA will require the development of cutting-edge technology and innovation, including the design of the world's fastest supercomputers to process data at rates greater than the current global internet traffic. SKA will enable astronomers to probe the universe in unprecedented detail. The SKA will also be able to survey the entire sky much faster than any radio astronomy facility currently in existence. This giant telescope will produce science that has the power to change our understanding of the universe and our place within it, so that the eternal wonder of looking up at the night sky is magnified by knowledge of its creation, composition, and architecture. From its mysterious birth, expansion, and fiery evolution over billions of years under the influence of gravity and physics, to the knowledge of where the matter that makes up our bodies comes from. And to answer questions we haven't yet thought to ask.